Chalk is the real-time feature engine. Let's say we're a bank that wants to make faster, more accurate credit decisions. We can quickly build a data pipeline using Chalk. First, we'll integrate data from 3 different data sources. Second, we'll join that data to create new features. Third, we'll create a training data set for machine learning training. And fourth and finally, we'll create a feature vector we can use to make a credit decision. Let's get started right away with the first step, which is data integration. I've already integrated with the first data source, which is user data. Here on the left-hand side, I have my Chalk project, and you can see I've defined a class called user. I've also told Chalk where that user data is by creating this PostgreSQL source, and I've mapped the user class to the user's table in that Postgres source, and I've done a little bit of extra mapping. And so, since I've already deployed this, I can come to the right-hand side where my notebook is, and I can query for data about users. And here I have that data. So Chalk went to Postgres, got the data back, and gave it to me. The second data I want to integrate with is data about loans. And this is slightly more complicated because this data is stored in S3 in a Parquet file. So I'll need to write a resolver to tell Chalk how to get that data. So here's my resolver, and I will go ahead and deploy this change. And what this resolver does is it goes to this location in S3, it reads that Parquet file, and it maps the data in that Parquet file to my loan class. And I can come over here to the right-hand side, and I can run my query, which basically says, given a bunch of loan IDs, give me that information. And in real time, Chalk is going to go to S3, download that Parquet file, parse it according to the logic that I wrote, and they give me all the data back in a data frame, and there's my data frame. So the third data we want to integrate with is actually an API, and this is an API called Rudder. And what Rudder does is Rudder basically gives you a trustworthiness score for a user. So we'll go ahead and we'll write a new resolver called getRudderScore, and given a user's ID, we can get a Rudder score, and here's how we can do it. We can go to this URL and pass the ID in, and we can get back a score from the JSON response. So with that, we've already integrated with all 3 data sources, and we want to get started on the second step, which is data joining. And so I'll actually go ahead and add Rudder score here on user, and we've now joined this API data to that Postgres data. So I'll go ahead and I'll apply that change, and now I'm able to run a query which, given a user ID, asks for data from multiple data sources. This is a very simple case of data joining, and when I execute this, Chalk is going to pass this user ID to both the database and the API and give me the data back. So let's go ahead and execute that. And there we go. I got a last name and a Rudder score. Perfect. But a more interesting case of data joining is maybe I want to know for every user the total monetary value of the loans they've taken out. So let's go ahead and let's add a field on user called loans, and that's going to be all the loans for this user. So it's going to be a data frame of loans, and let's tell Chalk how to get the loans for a given user. And basically, we want the loans where the user ID is equal to the user's ID. Perfect. That's great, but what we really want is the total loans for a user, and that's going to be, a float. So let's calculate total loans by writing another resolver. So get total loans, and that's going to take loan data frame, which is for a user, all that user's loans, and then for each of those loans, the loan.amount. And that is going to return for us user.total loans. And simply, we're just going to take that loan data frame and take the sum. And so we'll apply that change. And this is basically going to do an aggregation across multiple data sources in real time when we ask for it. And so because we've written this resolver, we now can write this query over here, where we're going to say, given a user, give me the last name from Postgres, the Rudder score from the Rudder API, and the total amount of loans by taking all that S3 information and aggregating it in real time. So let's go ahead and execute that, and Chalk is going to run all that logic and give me the information back in a single data frame. And there we have all of our users, their Rudder scores, and their total loans. And with that, we've completed the second step, which is data joining. The third step is generating a training data set. So this is very similar to what we've been doing already, except we're going to name this data set. And so since we've named it, maybe we'll call it training V1, we'll be able to get this data set back whenever we want in the future. It'll never go away. And that's really useful in case we want to reuse this data set in the future, maybe for backtesting, or maybe we get audited, something like that. And now we have our data set with all of our data that we're interested in for machine learning. We can actually get that data back in a number of formats. So here you can see I can get the data in pandas and polars or as a chalk data frame. I personally like pandas, so let's go ahead and do that. And there you can see I have all my information, including the total amount of loans, the trustworthiness score, email, etc. for all my users, and I can use that to train a machine learning model. So the fourth step is to create a feature vector we can use to make a credit decision. So we'll use the Chalk Query API to quickly get a feature vector. And this will be the information we need to make a credit decision. So this user has kind of a low rudder score and kind of a lot of loans, so probably our machine learning model will decide not to make a loan to this user. So thanks for your time, and we're really interested to see the kinds of things that you're working on. We hope to see you soon.